right, past the proton, we're going to talk about acids, bases, and proton transfer. Our objectives, we should be able to identify acids and bases by formula for Arrhenius, like we talked about yesterday. Arrhenius acids and bases. Write dissociation equations for acids and bases, and identify the acid, base, and their conjugate pairs. And by the end of it, we should be able to tell what is going to be the product of a reaction of an acid or a base. So, moving forward, dissociation equations. This is a review, so you guys don't have to copy this down if you remember it. If you don't, you can. I'll post this right after class, and you guys can watch it. So, the dissociation equations are when the ions separate in solution. We have our NaCl breaking down to its ions Na and Cl. Those are an aqueous solution. Magnesium nitrate breaks down to magnesium ions and 2 nitrate ions. You guys may be familiar with this because I may have given you guys an ion list or 3. So keep those handy because we will be referring to those later. So if you're right to... I guess I messed up my animations. But this is another example, the animation dissociation equation for calcium acetate. CaCH3ClO2 breaks down into Ca plus 2, and 2 of those I messed up. So let's just get off of the slide. Arrhenius acids and bases. You don't have to copy the examples because I think we put a couple yesterday. But Arrhenius acids dissociate to, they form H plus ions. So, like here, hydrochloric acid makes an H plus ion. Nitric acid makes an H plus ion. Bases make the OH minus ion. What do you think you get when you put H plus with OH minus? HOH. Ha! More commonly known as HOH. How many H's? H2O. So when you get an acid and a base, you make water. So if they're in the right amounts, you make a neutral solution if you have equal amounts of acid and base. The old story was, there used to be these door-to-door salesmen. They used to go to your store and they'd sell you stuff. They sold you knives, or one of the common ones is carpet. They'd try to get you to buy a new carpet from them. So one of the clever carpet salesmen, he would take a sample of their rug, a competitor's rug that was similar to the customer's rug, and pour some acid on it. It would be ruined. Then he'd take another sample of the customer's, he'd pour base on it. Believe it or not, the carpet was ruined. Because if you had a strong base and a strong acid on carpet, they're gonna be ruined. So then what he did is he mixed the acid and the base, and then he poured that mixture on his carpet. Nothing happened to his carpet. Why? Because he reacted forming water. So all he was doing was pouring salt water on the carpet. So that was his method to try to get to fool the customers using chemistry. So he was a clever one who probably paid attention in his high school chemistry class and made $1 million. And that was in 1945, so that was like $1 billion now. So that's it. Bronsted-Lowry acids and bases. I told you we'd talk about this. They're determined by hydrogen transfer in a reaction. Acids are proton donors. Bases are proton acceptors. Yeah, copy this down. So here's an example of a Bronsted-Lowry reaction. Guys, eyes up here. Consider the reaction NH3, that's ammonia, with H2O, water, making ammonium and hydroxide. So let's take a look at what happens. What happened to the NH3? It started off as NH3, right? And what did it end up as? NH4. How did that happen? Took one of the what? Took one of the H pluses, so it accepted an H plus. I made animations. What happened to the H2O? It gave up an H. The H2O started out as H2O and it gave the H plus away. So, oh, that was cool. NH3 ended up as NH4 by gaining an H+. It accepted it. H2O lost an H+. So NH3 gained it, so it's a base. H2O lost it, so it's an acid here. So water's interesting. It can be an acid or a base, depending on what it reacts with. So, because you can add an H+ or get rid of it. We'll talk about why later. Conjugates. This is something you guys want to write down. So this is the reaction we just talked about. The products have a name. So NH3 is our base. So the opposite, it gained an H+, so that's called our conjugate acid. So it has the H+ in the end is the conjugate acid. The acid is water. What lost the H+ is called the conjugate base. All right? So those are a couple key things. So let's try one of these. What time is it? Oh, good. We're almost there. We're running. We have a good amount of time here. So let's just do the first one. Let's label the acid base and conjugate acid and conjugate base. First thing, guys, I suggest you do whenever you're doing this is look at the pairs. So when we have our pair, we have H2O. What's the pair on the other side for H2O? Is it HSO4 minus or H3O plus? H3O plus. And what is our pair for H2SO4? HSO4 minus. So look at your pairs, figure out what happened before and after, and then label it. We'll talk about this one in just a sec. So what happened here? What happened to the H2SO4? Did it gain or did it lose? It donated a proton. So if it donates a proton, what does that make it? What's a proton donor? And we just talked about it a second ago. Not conjugate acid, just regular acid. So if this is the acid, what does it make the pair for it? The conjugate base. It's always the opposite. So H2O, what happened to it? Gained an H+, so it accepted the H+. So what does that make it? The base, and then therefore this is the conjugate acid. All right. So you know what? Let's quick. We're almost done, and we'll get started in this. Okay, you want to hand out some?
I'll do it if you want.
No. Yeah, just I think we have enough working pairs, so there's whoever's around. Whoops. All right. So moving on, guys. Almost done. Sit up. So acid strength depends on how much they separate. So what I want you guys to write is the last two bullet points. Strong acids and bases completely separate. Weak acids and bases partially separate. So those are 2 points. So key thing is, so here's a diagram. A strong acid, notice the protons, the H pluses. A proton is just an H plus. So just keep that in mind. So the protons completely separate from the negative ion or the conjugate base. A weak acid, most of them stay together. So the tendency is for a weak acid and a strong acid of the same molarity, the weak acid is going to have a higher pH. The strong acid is going to be more acidic. But here's another diagram I have to show. This is another schematic. So if you have a weak acid, see how only a very small number of the ions are freed. So we have 2 out of the, I don't know, 20 or so that have dissociated, but most of them stayed together. Whereas all of the weak acids, all in the strong acids have dissociated. All right. So that's it for today. No, well, for now. What you can do, we got our pass the proton. Denise, what's wrong?
So I put some cards down.
Guys,
Some of those packs of cards, there are 12 cards in each group. Okay, so you'll have to be able to share with people around you. So some of you have for 2, some have to share in groups of 3. Is that it?
equivalent.
Yeah, I know, and I have to keep. Go.
Who needs a copy?
What's the date today?
Oh yeah, if you guys want to go to the lab tables and work, that's fine too. Did you get... Alright. You guys have first? Out here.
Oh.
I couldn't find them earlier. I was right in front of me. I couldn't believe it. Vinicius.
Oh yeah, that's the time.
Oh yeah, you sick?
No, man, me and my mom got in the car accident.
Oh no, are you okay?
Oh, we have to start
Yeah, it is.
Wait, sort the cards in 3 groups. Right, so you sit on the line. Very comfortable. Bring your chair. Ow, I almost fell. No. I'm always trying to fight you. Every time I see a film, I sit down and on the fight. Which strikes me? You looking at my cards and you probably have them. Yo, my favorite.
One of these, when you turn one on, the other one goes on.
It's not that one. It's everything but it's not. Like some of them have this. There's water everywhere. I wasn't wanting. Like I think 1, 2, 4. Some of them have 1, 2, 3 have the same thing. Guys, focus. I feel like I'm driving a motorcycle. Come on. Guys, seriously. Isaac, stop! You're getting your butt. Stop! You're getting his butt. Stop.
You know what? It's work.
No, it's not. Okay, so four spaces to the right, 4 spaces to the left. Okay, how's that going?
What's the dot to go?
You want me to sort them? That's me. I will call your mom to see if you
No, she's showing you right now.
chatting.
No, it's more that.
You were not prepared.
You gotta have your head, you gotta have your body, or.
Oh no.
You know, he like said, I'm gonna do it now.
I've done it. Now.
That's it, having to spend party members.
Yeah, but there's more than 3 rooms there.
No, well, you have to do 3 groups. Of course you would, I know. Hey, hold them on. 3 groups, go.
Alright, I'm because these are acids. And then I think I'm gonna are gonna be one group that we're gonna
Just write down what's what. What's in one group.
Well, this is like.
Oh, the names?
A lot of these have 0.10. You just get some. Trying to say you had a girl with a good
Everybody okay? Insurance people.
The guy wasn't like, we didn't hit anyone, like, they hit like, so his voice was done.
That's for everybody.
Yeah, true.
Kill what?
Chemistry with
Yes, ma'am.
So I put them. Like you want the numbers.
Just do the numbers.
when you're afraid to say your phone when we're trying to get out.
Oh, yeah. All right.